All right, so good evening, everyone. Welcome to our day one of Python for AI ML. And I'm Madhav, and I'll be talking about the environment setup required for working with Python. So we'll be using two software for this. We'll be using Anaconda and we'll be using VS Code. So we'll teach you how to set it up today for like the first half, and then Devansh will come teach you Python basics. So let's look at that. Anaconda, it's basically it's a package where you can have a lot of Python distributions. It's used to simplify the whole framework for having lots of packages. Like when you're working with AI, you have a lot of packages to install, a lot of dependencies. So Anaconda will make it simple. It will avoid like conflicts when you're working with lots of packages. So that's why we're using Anaconda. And it also comes with a package manager, which will help you install these packages very easily. So yeah, for Windows, you can just, once you go to the link, click on install, you'll get this basic setup. So you can proceed with the defaults. Once again, you can just proceed with the defaults by checking the Anaconda for the default Python installation. And then you can complete it, hit finish, and that's it. It's very simple to set it up. For the most part, just stick with the recommended defaults. Don't change anything. And then we'll talk about VS Code. VS Code is where you'll be typing all your code. It's a basic text editor which can be customized into a almost fully fledged IDE. So you can get it from the link below. So all you have to do is accept the agreement and then check all the boxes and restart your computer to finish the installation. So it's that simple. Then as soon as you boot it for the first time, you'll get a simple walkthrough teaching you all the basics of using VS Code. So you should look into doing that and you'll be set up in no time. So that's about it for setting your environment. It's that simple. Once you have these two tools, you'll be able to work with Python and especially Python for AI and ML. You'll have all the packages ready. We'll be talking on packages as we go on. And right now, to save time, we'll be going ahead with Colabs. So Devansh will take over and show you how to use Colabs.
So good afternoon, everyone. Well, Python is a very basic programming language, basically. And it's used in a lot of fields. It can be used in data science. It can be used in data mining. It can be used in so many other fields. So it's a basic and easy to learn language, which can take you to many places. So it's a good place. It's a good language to learn at this point of time. So Google Colab is essentially a Google product, which is built upon a Jupyter notebook. So it's an online compiler essentially that can run Python code. And you don't need anything for this. All you need is the internet connection. So it's perfect for beginners as well as advanced people who use Python for machine learning too. So this is the page which you will be greeted with. So now let me just tell you how you make a new file in this. You just go to File over here and you click on New Notebook. And this is where I'm going to run my code. So now before writing code over here, let me teach you the basics of Python. Okay, so my name is Devansh. I'm a part of GDSC, and I'm going to teach you the basics of Python today. So Python, the number one thing that you guys need to know. So in Python, there's essentially no curly braces to show you that there's a block of code. Instead, we use something called as indentation. So we'll just write a normal, suppose, for loop. So a for loop in Python basically looks like for I in range n, suppose. So basically this loop will run for 10 times and the value of I changes from 0 to 9. So 0, 1, 2, 3 till 9. And now as you can see, my cursor is not at the beginning of the line. It's at a space. So that is the meaning of defining a block in Python. So in other programming languages, you would just make curly braces and you would tell like, this is my code. This is my block of code, but not in Python. In Python, you need to indent your code. So indentation basically means spaces. So when we talk about spaces in paragraphs, like normal writing, indentation is used to specify like this is a separate paragraph from the other paragraph. So same thing we use in Python. But when we use indentation, it basically tells us this is a different block of code from the remaining. So how do you get like what space do I set it at? So you just press tab once. So the tab key which you have on your keyboard, you just press it once and that is the amount of space that you have to give. And then you can just write anything like suppose print 0 and then print 1, anything. how do you run the code? You can see a button over here, the play button. You see, either you can click that button and it will run the code. So in the beginning, it does take a little bit of time to connect and run, but after the first run, it runs faster generally. One more way in which you can run code is you can press Control and Enter together. So that also runs the cell of code. So now, yeah, as you can see, all changes saved. It's working on it, and here we go. This is our output: 0 1 0 1 0 1 printed 10 times. Okay, now you'll be noticing this thing like all of this is kind of in a cell, which you can see. So Colab basically uses this kind of structure. You have an option to create two things: a code cell or a text cell. I'll just tell you what a text cell is. So text cell usually, as it tells, it's a text cell. You can add text to tell what you're writing in the code, to define, to make it look good. And also the Colab basically helps you. You can write HTML and other things. You can write basic Markdown language too. Now, what is Markdown language? I hope you all have heard of HTML. It's a markup language. So not using those complex tags, just using basic symbols. You can also write. You can also use certain letters to make your code look good. So suppose I add 2 asterisks and I write hello and 2 asterisks again. You'll see it. It made my text. It made my text a bit more bold, if you will. So this is basically Markdown language, which we can also use over here. And similarly, there's many more options here. You can make it italic. You can make a heading out of it by using another hashtag to make the heading smaller. So you can explore all these options. So now let me just show you a example file that I had created. So this is the example file that I've created. So as you can see over here, GDSC ASEB. This is a basic HTML command which is running here. So you can use HTML2 to make your code look good. And these are a set of markdown symbols which you can use too. Okay, then this for heading. Basically ordered list, unordered list. Okay, cool. Okay, so horizontal rule. So let me just show you how this looks like without the markdown being applied. So this is essentially the code that you will be writing, and this is the output on the right hand side, as you see. So double hashtag and reference would make it look like this. And to make this table, you need to follow. Well, we won't go to the complex ones. Let me just show you some simple examples first. Okay, so here you can see these 3 symbols. This is an acute symbol. So you might find this below your escape key in your keyboard. So you have to use this 3 times and then write markdown, and you will get something of a dark box, which you see here. So these are some of the markdown features that you can use. Okay, so now let's begin with Python. So indentation is a very basic thing which you guys need to always keep care of, is how much space to keep within a loop so that it would run correctly. Now next is about Google Colab, as I told you already. So it allows you to combine code as well as HTML, LaTeX. LaTeX is another thing which is basically used to show mathematical equations, square root symbols and all. So it'll make your code look better. And as you can see, Colab notebooks are Jupyter notebooks that are already that are hosted by Colab. So now let's go to data types. So in any programming language, there would be some primary basic data types which you use to essentially code. So over here, you have data types which include integer, float, which is very common in other languages too. Then you have something called as complex here, which I'll show you. Then there's Boolean, which is basically true or false. Now the other ones are set, list, and tuples. So these I don't think you might have heard before. So I'll just show you guys. So the basic integer, float, and complex. And also, yeah, a very important command over here, the dir command. So now I'll just click on a new code cell and I'll just write dir of suppose 1. So now 1 is my 1 is basically of the type integer data type. So when you write dir of 1, dir basically stands for directory. But when you type this command, it will show you all the possible methods that you can use with the integer, which is 1. So these are all the methods that you can use. So this is also a helpful feature just to see what you can do with the data type that you have. You can try with any other data type. You can try writing true. You can try writing anything in single quote or double quote to see what pops up. Complex. So I'm pretty sure you guys have heard of complex numbers in math. So there's a way of representing that in Python too. So all you have to do is add a j over here. So in math, you add an I over here, which is root of -1. Over here, you just add a j to make it complex. Add a new code. Suppose anything like a is equal to 2 plus 3j. So this is my complex number essentially. And in Python, another thing, in traditional programming languages like C, you would first have to declare like int of a, and then a is equal to 3, something like this. But not in Python. In Python, the declaration of what type of variable it is happens while you assign it. So it's dynamic. You don't have to tell like a should be of type integer. Python understands that when you equate it to some value by itself. So that makes it faster too, faster in typing. Next is set. So set items are unordered, unchangeable, or immutable, and do not allow duplicate values. So set is, you could think as of an array essentially, which is unordered, unchangeable. So as in once you have made this set, you cannot change it. It is as it is for the rest of the code. And it is unordered. So unordered as in normal arrays, you can reference every element by giving a of 0, a of 1, but you can't do that in a set. A set is unordered. And also, since I just told you guys that no duplicate values are allowed, so you can't give 1 2 times. It'll just show the one only once. So the values of true and 1 are considered the same in a set and are treated as duplicates. So what that means is basically in a set, if you have 2 elements, one is true and one is the number 1, set will consider both of them to be same and take only one of those values and remove the other. So let me just show you an example of set 2. So this is my set A, which is basically, as you can see, 1, 2, true, and 3. So what I just told you guys is true and 1 would be treated as the same value. So let's just print our set over here. And also, guys, for commenting in Python, you just use hashtag. So that comments your line. Yep, there you go. 1, 2, and 3. It hides the value true. And how you add elements into this set is you use the add function. So a dot add of 0. So you're adding 0 to the previously built set. And now there's also a way in which you can combine 2 pre-existing sets. So you can do that by the update method, update function. You just do a dot update of C, and C being another set. So basically that combines set C into the set A, and then you can just when I printed A, you can see here 1 2 3 4 5 6. It is seen, and you can remove elements too. So in normal array, you can basically choose every element by giving its index value. But over here, to reference the element, you need to give a separate key value. So that key value can be anything that you wish. So dictionaries are used to store values in key value pair. A dictionary is a collection of ordered, changeable objects and do not allow duplicates. So yeah, basically a key, the key of a dictionary cannot be same for any other element. And why I have put this asterisk on ordered is, as of Python version 3.7, dictionaries are ordered. In Python 3.6 and earlier, dictionaries are unordered. So this is a pretty new update too, which has made dictionaries ordered. Sets, as you saw, it's defined by curly braces, right? So dictionaries too are defined by curly braces, but they have a different way of showing which is the key and which one is the value corresponding to it. Okay, let's just make a new dictionary. So let's just make a dictionary C, suppose. And we can give it any key. So suppose key 1. And we can give it any value, suppose 120. And we can make another key, suppose key 2, and give it a value of 121. So this is my dictionary, which has 2 keys, key 1 and key 2. These are the name of the keys. And their values correspondingly are 120 and 121. Now, how do I call the value 120 now out of this? So if this was an array, you would just do like C of 0, right? But over here, you have to do C of key 1. That's it. And one more thing in Colab is you don't have to write the print statement at the end. So suppose you want to print anything at the last line, you just need to write it. You don't have to write the print statement, but that doesn't work when this is not your last line. So if I write something else beneath this, like print GDSC, it wouldn't print the value of key 1. You would just go to this command over here. So let's just comment this and run. Yep, 120. And how I'm running this again is pressing Control and Enter. And Colab is something that you can use even in your semesters. It's quite useful. It's what I used to. Dictionaries are done. Now lists. So list is your very normal array. It's a 1D array. There's nothing else to it. It can store multiple values. It can store duplicates. You can change the values. You can do anything. And they're defined by square brackets. So let's just build a list here too. So no, let's just start this in a new cell. So a list A, which can have values 120, 12, something, some sort of text. Compile it. So there you go. We have a list built. And now how do we call elements? By their index values. So A of 1 would be 12. And so on. Now, how do you add values to a list? You use the append method. So in this append method, you could add anything. A.append of 0, and then you could just print A. So as you can see, 0 has been added to the list now. I'll just show you guys one more thing. So how do you name your documents in Colab? You just click on this over here, untitled. For me, it's 11. For you, there'll be some other name. And you can just name it anything, like testing 1 or anything you want. And this will technically get saved in your drive. So the next time you go to the Colab website, it'll give you an option to open up new files, like it's giving me. So these are all the files that I've already made. So it's giving me an option to open them. List done. And now tuples. Tuples are also used to store multiple items in a single variable. A tuple is a collection which is ordered and unchangeable. So ordered as in you can reference it using index values. Unchangeable as in once it's made, you can't change the values at the given index. So it's just the same thing again. So we'll just move on to the next, which is string. Okay, so slicing is a very important thing too in Python. What do we mean by slicing is basically a given string. Suppose I'll just write my name, Devansh. And you guys can follow me too in this. You can type your name. Now, how slicing works is you just type the variable name, and in square brackets, you mention the starting index of the slice. Slicing means you're cutting the word essentially. So the starting index. So I want to start my slice at index 0. That is, I want my D to be included in that. And I want the slice to end at H. That is my first name. So 0, 1, 2, 3, 4, 5, 6. So 6 should be my ending index. And I want you to take one step at a time. So that is include every letter until you reach 6. So yeah, and also guys, basically arrays, lists, everything. Indexing always starts from 0 in Python. So that's also a thing. Now, if I do this, you guys might notice like the H is missing from my name. The reason being in Python, when you do slicing, the starting index is always considered, but the ending index is ignored. So you have to give an extra index to tell it like stop just before that. So if I give 7 now, it would work. Even though my name is 6, I mean the index of H is 6. I would have to give an index of 7 to tell it to stop just before 7. So that's how slicing works in Python. So you guys can try with your names too. So that would be slicing. I'll just tell you guys, Colab is also a very nice thing. You don't have to install much in your system. You can use it for anything. And we're going to have a session on machine learning too. So we're going to use Colab for it, because machine learning requires you to import a lot of packages. So I'll just show you guys what packages are for 1 second. Okay, so these are nested loops and all, which we'll cover in the next session. Here, okay, so import random, import string. So random and string here are basically packages. So if you were using some other compiler, suppose Anaconda or VS Code, you would have to install these packages before. But in Python, in Colab, you just have to call them. And also for installation, you just have to do pip install, and it doesn't take that long too. So string.ascii lowercase, print C. So yeah, this is how packages work. And I'll just tell you guys the operators too. There's the addition operator, subtraction. This is multiplication, division. So I'm hoping you guys know this already. Modulus, which basically gives you the quotient. And then there is the double asterisk, which basically means to the power of. So this statement would mean a to the power of b. And this double / basically means floor division. So after division, whatever value you get, it converts it to the lower integer. So if you get 4.3, it would convert it to 4 and give you. So that's it, guys. Thank you, guys.